Hello again. This is the fourth video for data structures. As I said before, I'm basically following the Dale Weems Richardson book, which is listed on the syllabus. Now, with that book, the next item that we need to talk about, the next item we need to talk about is an example. And this is an example that you know, but we'll try to see how we might think of it as an abstract data structure. The example that we're going to do is an unordered list. Now that's we'll view that as a collection of elements. We will not take a stand at the moment on what kinds of elements we're putting in there. All the elements of a list will be the same type. So we might have a list of int, we might have a list of string, we might have a very complicated list. Now, the idea is that we're going to write this ADT without getting into those details. Well, what distinguishes a list from other possible collections? And the technical definition of a list is that every element except one element has a unique predecessor, and every element except one element has a successor. That's a fancy way to say that they're in linear order, that we can line them up. And a simple example would be like 4, 12, 9, 100, 22. In this case, 4 has no predecessor, and 22 has, and my usual problem with writing, predecessor, and 22 has no successor. And all the rest, 12 is the successor of 4, 9 is the predecessor of 200. Now, I think if you're thinking, you may say, hey, he's giving a fancy name for an array. And an array is a way to implement the list. But a linked list is also a way to implement the list. There's more than one. There may be others. And everything we do should not depend on which way we're talking about that. Those are details, and we'll worry about them later. Now, the question that comes up next is, before I forget it, notice these elements are not ordered. We have a first element, a second, a third, a fourth, a fifth, but the values are not in order. Okay, so let's see. We might have another example, the elements. Pardon me. The next word I want to define is key. We have to. We need to be able to get into these things. We need a way to determine the order. So we need a way to determine the order of the list. Now, if you think of arrays, it's very simple. It's the index. If the implementation is array, the key is the index. If we're looking, if the implementation is a linked list, if the implementation is a linked list, we probably have a pointer. To the current element in the list. Another example. It's possible the elements of the list might be pairs of telephone number, name. We could use the name as a way of getting in, finding things. The key could be name. However, the list is not ordered either by name or by telephone number. So the key is how you find something. And you're used to an array method of working with lists, so you're probably more used to the idea of the index than any other method. Now, the next thing we do when we talk about an ADT is we try to figure out what would people want to do with this. This is the logical level. What is it that a person needs to be able to do? And there's three sort of categories here. One category is transformers. These are the things that change a list. And there's three of them we might think of. Make an empty list. Now remember that in a class that would be a constructor probably. we would have add an element, and we would have delete an element. So those are the things we need to be able to do to keep working with the list. Now, the next thing people talk about are observers, but I think you might be more used to calling this mutators. At least that's the name I used last semester in 104. The mutators are getting information. The observers are getting information. So we might want to determine if the list is empty. TY. So that means we probably are going to have to have some way of keeping track of the size of the list. We also want to be able to get the length of the list, and we want to be able to get an item from the list. So those are the things that we need to do in that case to sort of manipulate things in the list. Now there's one other set, and they're called iterators. And in this case, it might not be quite as easy. Iterators to say what these do. One, for example, would be to open a list by reading values into it, say. Another one would be get the next item. So I'm not doing well with this reading. The next one would be get the next item. Now that might mean that we are going to have to keep a pointer if we do it, or keep track of where we are, however we implement it. Now, so far, this is the logical level. We haven't talked about the implementation, nor have we talked about what's inside the elements. I'm running I'm at a good point where I can stop. So I'm going to stop here, and in a few minutes, I hope I'll send out another one. So good luck.